All right, in this video, we are going to learn how to identify outliers mathematically using IQR. Up till now, you've always just been like, yeah, that looks like an outlier. It's really far out there. Now we're going to learn how to actually decide using numbers, something impartial, whether something is an outlier or not. So let's start with the data set. We're going to go with 10, 2 13s, 14, 3 16s, 17, 19, 20, and 28. Oop, there we go. All right, so at first glance, that 10 is kind of small. They're in order. The 28 looks kind of big, right? So this is the one that we're wondering, is it an outlier, right? It's pretty far away from the others, but we don't know. Maybe it's an outlier. And so we're going to do some math to prove it. Now, there are multiple methods for identifying outliers. At the Algebra 1 level, we are only worrying about identifying them using IQR. There's another way using standard deviation, but we're not worrying about that one yet. We're just doing it with IQR. Okay, so the steps involved are, first, we have to find the IQR. So they're already in order. There are 11 numbers. 1, 2, 3, 4, 5. So 16 is my median. 1, 2, 3, 4, 5. 5 on either side. That leaves me with 5 here. So the middle one is my Q1. Middle one here is Q3. So then my IQR must be 19 minus 13 is 6. Second step, this is where the rule comes in. Anything that is 1.5 times the IQR plus quartile 3 or minus quartile 1 is an outlier. So Q3, this is definitely something you want to write down. So Q3 plus 1.5 times the IQR gives us like the upper bound for outliers. So in this case, that would be, it gives us like the upper bound for outliers. So 19 is Q3, IQR is 6. So 19 plus 1.5 times 6, 1.5 times 6 would be 9. So 19 plus 9 is 28. That is exactly the number we have there. It has to be above that to be an outlier. So we're safe for now. Let's check for lower numbers, not that there's any likely candidates, but just to show how it's done. So to do a lower outlier, you would do Q1 minus 1.5 times the IQR. That would give you the lower bound for outliers. So in this case, that would be 13 minus, and then 1.5 times 6 is going to give us 9 again, right? But I'll write it out. 1.5 times 6, 13 minus 9, which gives us 4. So what this means is that anything more than 28 or less than 4 is an outlier. So in this situation, we didn't have any, right? We had a 28, but it needs to be more than 28, not more than or equal to, just more than. So 28 is safe. So no outliers. 28 is safe. All right. Another way, or something else to think about here, just because we identify something as an outlier, that doesn't necessarily mean that we don't use it, right? Sometimes we exclude outliers from a data set and we don't use them because they mess up the data, but sometimes we want to include them because they're telling us something important about what's happening in the data. So we have to think carefully about whether to use an outlier or not once we've identified one. In this case, there were no outliers, so we didn't need to worry about it. All right, practice problem. So on this one, I gave you the actual numbers. This time, I'm going to give you the box plot. So that means less math for you to do because I've already done it, but you have to make sure that you understand what the different pieces are. All right, so here's our box plot. I've tried to draw those right on the lines for you. The question is the minimum of this data set an outlier? So use our equations from up above, extract the quartiles, minimum, maximum from in here so that you have enough information, and good luck.